could also look up data you recorded previously. So if you wanted to compare a flash you did today with one you did yesterday, you could also do that. Okay, so that is the fluorometer basics. So when you go to set up a flash, again, if you recall, the multi-phase flash should really be used if you're working with highlight grown leaves, whereas the rectangular flash should be used if you're working with dark adapted or low light grown leaves. So the multi-phase flash has different settings that you can customize. Again, I would begin with the defaults and see what your data looks like. The multi-phase flash has the 3 different phases, the first phase, second phase, and third phase. You can decide the intensity of the saturating flash. Right now, mine is set to 8,000. The maximum for our fluorometer is around 16,000 micromoles. So you can see 8,000 is about half of what the instrument will allow you to do. And then you can customize how long each of the flat phases is, and then the percentage of drop that you have in your ramp. The ramp percentage, I would always leave at 25%, but you may need to adjust the timing of your phases depending on what your data looks like. In our manual, our version 2 manual, we have a lot more detail on how to customize this flash and set it up for specific leaf material. So I would really encourage you to read that and kind of follow along in the manual to provide additional details. A rectangular flash is what it sounds like. It's rectangular. The light comes on, stays at a constant level, and then goes out. And the parameters that you would customize for this are your saturating flash intensity, and then how long you want that flash to be. And again, I would start with the defaults and see what your data looks like. These may be appropriate for your plant material. Again, more information is in our manual on how to customize the fluorometer options depending on your plant material. Okay, that is environmental control. Now we'd like to go through some warm-up tests and just do a quick check of your instrument before we have you go through and take survey measurements. We'll see how much time we have for all of this today. We may run out of time to get too far into survey, but we'll give it a try. So I'm going to turn it over to Elizabeth now. I'll stop sharing, and she's going to talk about the warm-up tests.
Okay, so I'm going to use the power of VNC, and I am going to connect to the instrument that is next to Shannon and not next to me. So let me get VNC started for myself. And hopefully that will work. I am going to briefly make sure that my cable is connected because I am concerned that it is not. So just a moment. I'm going to disappear off the camera and hope Okay, it looks like we have fixed the cable problem that I had, so let me try connecting to VNC one more time. VNC is extremely powerful, but occasionally it does strange things. Aha, there we go. Okay, let me share my screen. And there we go. Okay, so I can see that everyone can now see my screen, and that's excellent. So what we're going to do is we're going to now do the warm-up tests. And so the warm-up tests are designed that they just make sure that the hardware and the software is working for your instrument, and you should do them every single day. So every time you take measurements, well, every single day that you take measurements. If you're not taking measurements, no need to do the warm-up tests. But before you start your measurement day, we need to do our warm-up tests. So what I'd like you to do is go up to the Startup tab, and then go down to Warm-up System Tests. And what we do with the warm-up tests is we go through a whole series of different things, and they take about 10 to 15 minutes to do them. And normally what we would do is we would just press the start button, and then it would go through it individually. But since this is a brand new instrument and we want to talk about what the warm-up tests do and how they work, we're going to go through them individually. And if we have any failures, we're going to talk about it. So to go through them individually, you'll tap on the little blue triangle, and then you'll go to the first test, which is cal-coif test. And this tells you whether the chamber needs to be open or closed and what it does, that it checks the user calibration coefficients. It makes sure that the calibration coefficients stored in the memory make sense. So you should go ahead and close your chamber, please, go ahead and click it closed. If you don't already have it closed. I think you did from the last time I saw it, but make sure it's closed, because some of the chamber, some of the tests will not work well if it's not closed. Once the chamber is closed, go ahead and press start. And this is a really fast test. It's done. So it just went through and just checked the memory just to make sure that everything was working properly. The next test, this almost never fails. The next test we have is called the sensor check. And what we're doing here is just making sure that all the sensors are reasonable. Temperatures, pressures, all those kinds of things. So go ahead and press start on this as well. You may notice when you're running system tests that you've got a couple of different warnings. So we've got a warning here, restore flow, constricted flow, flow as low. Don't worry about warnings during system tests, because those are just letting us know that the system test is running. And so there are conditions that we wouldn't normally want to take measurements. If we see those warnings when we're not doing a system test, then we should worry about them. And I did notice a few when I was looking at GK's screen. So we will fix those before we try to take some measurements. But hopefully we did not have any failures in sensor check. We almost never do. The next one is flow valve function, and we do need to have the chamber closed for this test. What we're doing is just testing to make sure that our flow split and match valve are functioning. Remember when we talked yesterday about the way the valves work in the sensor head? So we can send air one way or the other. We want to make sure that's all working. So go ahead and press start. And the other thing you'll notice here is we've got sys test up in the corner. This is just a notification that there's a system test. I had all passing grades for my flow valve function. I can't see GK's screen, so can you tell me if any fail? He's got all of them running. Okay, well, okay, that's fine. Well, then you, GK, keep running that, and I will individually talk about what these are while we go through it. The pump speed test tests the flow at low, medium, and high, just to make sure that what we ask the pump speed to do, we get. So what we're going to do is we're going to go through different set points and say, we expect it to be this, is it actually this? And this is based on when your instrument was manufactured, we established kind of a baseline of, if I ask for this much flow, I should have that much response. How much power we give to the pump, things like that. Because remember, all of these things are electronics based. So if I ask for a flow rate of something, then what it needs to actually do is say, aha, I need to open that valve this much so that I get the flow rate that was requested. Or in terms of CO2, we ask for CO2 concentration. Okay, I need to open the valve this much to get that CO2 concentration. I passed my pump speed test. No, I don't want to run it again. I want it to go back. I'm going to go down to valve leak, and this is just related to the pump speed test. We have quite a few tests that are related to flow and valves and pump speeds, just because it's so important to truly understand the flow that's going through our chamber and how it's all working. So one of the things that you can see is we've got 3 parts in our screen here. We have the status of the test, we have a graph, if a graph exists for it, and then we have a log down at the bottom. And we can make the graph bigger and the log smaller, or we could do it the other way. And it doesn't really matter which way we do it, it's really about what you prefer. Some of these system tests take a little bit longer than others. Some of them are very fast. So this is one of the longer ones, because what we're doing is we're changing a couple of different conditions and seeing what happens. If we don't have any failures, then we just see pass, 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 pass in our log. If we have a failure, then what we'll see in the log down here is usually a suggestion. So you did this, try changing that. I'm going to check chamber overpressure. Remember, we talked about the overpressure valve and how that's useful in a situation where we might be using a small chamber, like the small plant chamber, where we have a little bit of growth medium that we might want to suppress the growth medium behavior. Okay, I passed that one. Sample cell cal is one of the chambers that allows us to determine exactly how the instrument gaskets are working and everything like that. So it just kind of fine tunes the leak or lack of leak in the chamber, so that when we do take measurements, we have an even better idea of how much of the gasket leak is being created.